we're going to take a tour of the machine shop here and show you what some of the tools that you may not have are, especially the large stationary tools, so that if you need to have something done for you, you'll have a little clue as to what tools are available and what to ask for. Most of the robots are built primarily of aluminum. A lot of them will use some wood. Turns out that a chop saw like this, a powered miter saw, is capable of cutting aluminum. And if you want to do that, I'm going to recommend that you get a special blade. The blade on this saw is a Freud non-ferrous metal blade. You can get them at Home Depot. They're red, and the teeth have a negative rake, which means it won't grab the metal. So this blade, in combination with this saw, is intended to cut aluminum. So if you would like to use a power miter saw, if you need to make a lot of nice cuts, this is a good way to go. I'm just going to make a little test cut here. It works a lot like cutting wood. You'll want to go a little bit slower than you would for wood, and you'll want to listen to the sound of the saw. If the saw sounds like it's laboring, then you need to slow up a little bit. Aside from that, it works great. Most of the other teams have been using these blades for quite some time. So this gave you a nice, clean, and straight cut that you oftentimes can't get with a hacksaw. And so there is quite an advantage to using a power miter saw like this. Pretty much any 10-inch miter saw will work. This one is a Makita. I've also used Ryobi, DeWalt. They all work just fine. It's a standard 10-inch blade. Again, it's a non-ferrous metal cutting blade. Now, a really important thing that you need to realize about that non-ferrous metal saw, it does not cut steel. Don't try it. You'll end up with throwing carbide teeth around the room, and it's not much fun. If you need to cut steel, for example, drive shaft, the 5/8 axles, or any other steel parts, a hacksaw works. Or if you need to cut a lot of it, you might want to use a tool called a horizontal bandsaw. You may or may not have one at your own facility, but a lot of the teams do. So let me show you how a horizontal bandsaw works, and this way you'll know to ask to see if another team has one for you. It's a bandsaw. This is the blade. The blade runs as a loop around the hubs of the saw, and it's used to cut long pieces of metal. So I'm just going to turn it on here. The saw automatically feeds itself, and you can just sit and wait for it. It'll actually shut itself off when it's done. As you can see, it's just like a hacksaw. It's a continuous hacksaw blade, and it makes pretty short order of a cut like this. This is a piece of 5/8 shaft. It will probably take 4 or 5 minutes of hacksawing time to get through it, and it looks like this saw probably did it in about 45 seconds, somewhere in there. So if you don't have one and you need to cut a lot of shaft, you might try asking one of the other teams around if they have a horizontal bandsaw. Another very important tool, a machine shop tool that you may or may not have access to, is called a lathe, L-A-T-H-E. And this is it here. A good way to think of it is lathes work with round things. For example, this shaft or this round rod, I can use this machine to make the diameter of the shaft smaller. I can also use it to drill a hole in from the end. And you can also create various shapes using a machine like this. These are industrial strength machines. If you're completely unfamiliar with one, you should probably make sure you get checked out by someone and trained by someone on how to use a machine like this. This is a medium-sized lathe. They come in many different sizes. Some of them are very small. Some of them are very large. This is just sort of a medium-sized one. It has a whole bunch of components and dials and knobs, but that I won't go into here. But I will show you a little bit of what a machine like this can do for you, so that if you need to have a part made or manufactured, you'll know what to ask for. So when you're using a lathe, you put the material to be worked in this thing called a chuck, and you close the chuck, and you can see that it's gripping the workpiece and holding it steady. And this will turn. And as that turns, you use a cutting bit, such as the one on the end of this tool here, to make cuts in the material. The next machine I want to show you is one that you'll hear this term quite a bit. It's called a milling machine. A milling machine is a very versatile tool that is used to shape metal. If you're familiar with woodworking at all and have ever used a wood router, this is like a big router for metal. These machines can handle steel, they can handle cutting aluminum, they drill, and they can cut slots, and they actually can do quite a bit of stuff. They're very big. This machine weighs about 3,000 pounds, so it isn't something that you would necessarily be able to borrow. If you don't have access to one, you'll probably have to find somebody who has one that you can go and they would be able to help you. Let me show you real quick some of the functions that this machine does, just so that you're aware of what you're asking for. A milling machine is a lot like a drill press, a very big, powerful drill press. I'm holding up here a drill bit, and you can see it has two cutting edges on the bottom. And normally when you drill a hole, it cuts vertically and shaves away the metal. The bit that's in this machine right now is called an end mill, and an end mill can cut vertically, but it can also cut horizontally. And what that allows us to do is it allows us to not only drill a hole, but we can also cut a groove or a slot in metal. And that is sort of the power of a milling machine. Okay, so what we're going to do with this workpiece is we're going to drill a hole, and then we're going to elongate the hole into a slot. So by turning on the machine, I'm able to get the hole drilled, just like a drill press would. Now I've got a hole drilled, and I'm now going to move the workpiece in the z-axis, or the y-axis. And as it's moving, the bit is cutting a slot. And this is a very useful thing if you need to have a bolt hole that's adjustable, for example. If you're not exactly sure where something's going to line up, or if you need to move something, it's a very handy tool to be able to do. here you have not just a hole, but we've cut a slot. The next thing you might occasionally need is something called an arbor press. This is an arbor press. It's basically a ram that comes down and is able to apply a great deal of pressure coming straight down. And in fact, this one should be able to generate about 6,000 pounds per square inch of force. You would use a machine like this to do a press fitting of, say, this bronze bearing through one of these holes. So you would line this up and you would use this, this arbor press to press this piece down into place, and so that it would hold nice and stiffly. You may or may not need one, but that's what an arbor press does. This machine here is called a TIG welder. It's used for welding aluminum and steel. Specifically, if you need to weld aluminum, you need to do it with a TIG welder. These are kind of tricky to use. It's not something that you can walk out and do right away, but you'll hear the term quite a bit, TIG welder. This is kind of a typical one. It has a big energy supply here. It has a tank of an inert gas. This is using argon. Sometimes they use helium. And it uses this special electrode to create an arc to melt the aluminum, and it causes a nice weld to be formed. Again, this is something that you may or may not have access to, but if you know what to ask for, somebody in the world's got one for you. So as you can see here, this is a weld. These two pieces of aluminum have been melted and fused together using the TIG welder. This unit is called a drill press. It's a large stationary drill that you can use to drill holes. If your team was going to invest a couple of $100 in a stationary tool, this should be the first thing that you think about getting. They're very versatile. They do a great job at allowing you to drill very accurate vertical holes. They're really not that expensive. I think this one cost me about $300 or $400. And it's a pretty good size one. You can get smaller ones for less than $200 that will do a fine job for you. This one has a 5/8 inch chuck. I would get at least a 1/2 inch chuck on your drill, and make sure that it has the ability to change speeds. This one changes speeds by a series of step pulleys up here, and it allows you to vary the speed from all the way down, or from as high as about 2,700 RPM all the way down to about 200 RPM. Again, this is a great tool to have, and it's actually a pretty important tool to have access to.